Welcome to my class. Today we see hyperconjugation effect. You know that here electron displacement effects. There are four different types of electron displacement effect. One is inductive effect, electromeric effect, resonance effect or mesomeric effect. The final one is hyperconjugation effect. We are going to see the hyperconjugation effect in detail. Generally what is called the electron displacement method you all know. In this the electrons in a molecule moving within a molecule. It's moving within a molecule. That is called electron displacement effect. Now we see hyperconjugation effect. What is called hyperconjugation effect? Suppose I take an alkyl group. You see, I take an alkyl group containing at least one alpha hydrogen, on alpha carbon. At least containing one alpha hydrogen on alpha carbon is attached to you see, alkyl group having at least one alpha hydrogen on alpha carbon is attached to. Suppose I take, you see, CH3 CH2. It is CH2. I will tell you what is called alpha carbon. All these things I will tell you here. This alkyl group I take. When then alkyl group having alpha hydrogen on alpha carbon is attached to carbon-carbon double bond containing system. That is called unsaturated carbon atoms are attached to unsaturated carbon atom, or this alkyl group containing alpha hydrogen on alpha carbon attached to carbocation is attached to carbocation, or it is attached to free radical, carbon having hard electron. So when an alkyl group having at least one alpha hydrogen on alpha carbon is attached to carbon-carbon double bonded system, or carbon having positive charge, that is called carbocation, or that is attached with carbon having single electron, that is called free radical. In this case, this alkyl group is able to release electron. This alkyl group is able to release electron. This alkyl group is able to release electron. This releasing effect is called as here hyperconjugation effect. What is called hyperconjugation effect? When a alkyl group containing at least one alpha hydrogen on alpha carbon is attached to carbon-carbon double bonded system, or carbon having positive charge, or carbon having single electron, this alkyl group is able to release the electron. That releasing electron, that effect is called as here hyperconjugation effect. In this effect, what happens here means it involves which one? Hyperconjugation effect. It involves delocalization of delocalization. That means you all know that here moving of electron, that is called delocalization of sigma bond electron, and it is pi bond electrons. It is delocalization of sigma bond and pi bond electron. If I go for a resonance structure, in the resonance structure the delocalization will happen, but the delocalization is in between the pi bond electron. But in this case, the hyperconjugation effect, it involves the delocalization of sigma and pi bond. But this effect is otherwise called as what to say? What is the name of this effect? Other name is called no bond resonance effect. It is called no bond resonance effect. It is called no bond resonance effect. Then I will tell you the meaning for what is called no bond resonance effect. All this is it not here? Right. Let me take an example and I explain what is hyperconjugation effect. Then I take here, now I take an alkyl group. You see, I take an unsaturated system like this. It is carbon, double bond carbon I take, and this one I attach with one alkyl group, CH3. I take one alkyl group, this, then I take here it is CH2 and it is CH. CH. Now I take this is called carbon-carbon double bond containing system. To this attached carbon atom is called as here, this carbon atom is called as alpha carbon. This alpha carbon containing hydrogen. If the alpha carbon containing hydrogen, it will show hyperconjugation effect. It will show the hyperconjugation effect. Then I will tell you how it shows here hyperconjugation effect. Now for my convenience, I write this as here C, it is H, it is H, and this is H. Then I take this, it is C, it is here this side H or this side H, it is double bond, it is C, here it is CH2. Here. Now this carbon is surrounded by how many sigma bond? 1, this side 1, 2, 3, 4. 4 sigma bond containing carbon is sp3. This carbon is sp3 hybridized carbon. This carbon, you come to this carbon, it is surrounded by 1, 2, 3. 3 sigma bond only, because here we have 2 bond. One is sigma bond, another one is pi bond. So this one is sp2 hybridized carbon. When a sp3 hybridized carbon is attached to carbon double bond, or when sp3 hybridized carbon is attached with carbon having positive charge, or when sp3 hybridized carbon is attached with free radical, that is called carbon dot, that is 1 electron, what will happen? Hyperconjugation effect will happen. Then I draw the structure. I take what example I take here? Propene I take an example, propene. What is called propene? This is called propene. This is, for my convenience, again I write this as it is H, it is H, it is H. Here it is C, it is H, it is double bond CH2. What is hybridization in this case here? Let me explain here. I take this carbon, listen to me carbon, this is the carbon, it is C. What is that? This side one hydrogen, this side one hydrogen. Now you come to that here, it is here. This side one bond is here. This side, it is one sp3 hybridized orbital, it is one sp3 hybridized orbital, it is one sp3 hybridized orbital. Here, this is one sp3 hybridized orbital, one more. What is that? It is one sp3 hybridized orbital. Here one sp3 hybridized orbital. It is with hydrogen is bonded with this, that it has here 2 electron. One electron is the electron of hydrogen, another one electron is the electron of a carbon. This is, so in this case now you come to this carbon, it is attached with hydrogen. It is attached with hydrogen. This side, what is here? Here I draw here, it is single bond, it is carbon. How many hydrogens we have? 2 hydrogens. 2 hydrogen. Here already we have double bond here, 1, 2, with this here 3 sigma bond. Here one double bond is there, that is called here pi bond. The pi bond means you all know that here the electrons which are involving in the pi bond formation is not present in hybrid orbital, it is present in unhybridized orbital. I draw this here, unhybridized orbital of this. Now how many electrons it has here? Here it has 1 electron, and this one the pi bond formation. This one is similar to this one, both these are same. This is same. Here you see this one is called here nuclear axis. Above and below the nuclear axis, electron density is higher. There only what we get here means a pi bond formation is this. Pi bond formation is similar to this. It is just like this. It is something like that. It is called a pi bond formation, right? This one is similar to how we draw the structure here. This is carbon, this one is here hydrogen, this one is hydrogen. This is, here we have here a double bond, here we have here 2 electron in this here with hydrogen, and this side here it is single bond, here it is a CH, here it is CH2. What we draw here means it is just like here, we can go for drawing like this. This is pi bond formation. It is similar to this. Both are sorry, all these three are same here, but I have shown here how the pi bond formation, it is just like this, above and below. This is now what happens here due to the hyperconjugation. What will happen? It gets a resonance with. What will happen here mean the hydrogen present in this alpha carbon. This is called carbon-carbon double bond system. To this attached carbon atom is called alpha. It is called here alpha hydrogen, carbon. This is called here alpha carbon. Attached hydrogens are called here alpha hydrogen. These three are called here alpha hydrogen. Out of these three alpha hydrogen, this alpha hydrogen, see that this alpha hydrogen, what will happen? This will lose both the electrons present in the bond and it leaves. Then what happens here means in this case, see, it is H, it is H here. This hydrogen is just like here, it is plus. Now what will happen in this case here? This one. Then I will tell you where that electron moves. Here this is a carbon, and we have here hydrogen in this case here. Then we have this is and single bond, it is CH2. Then we have here this is. Then what will happen in this case? You see here 2 electron, all these are there. Here how many electrons? Here in this already 2 electrons are here, but this hydrogen is losing both the electron and it leaves as H plus. But here it leaves as H plus means it remains as H plus, it does not move anywhere. I will tell you here what happens to this. Now what happens in this here 2 electron is there, those 2 electron, one shifted here, one is left here itself, another one shifted here. Already we have one more electron here, this electron is shifting here, that goes here. Now you see the 2 electrons present here, is it not here? Then one comes here. Already we have 1 electron, that electron shifts here. Now here this is the 2 electron, out of 2, 1 is here, 1 has gone this side, then already 1 is here, then after getting 1 more electron from this, it is become CH2. Now it gets here negative side. Now what happens here means this electron, it forms here pi bond. Then I draw the structure for this. How the structure will be? Now I take here, it is C, it is H, and it is here H. Now I come to here, it is CH. I come to this, it is CH2. Right? What happens here? Here pi bond. The pi bond formation I show like this. Then it is called nuclear axis. Above and below the nuclear axis, the electron density is higher. It forms here pi bond. But in this case here, what will happen in this case? Now here this is having negative charge. Now I take here an example here. This what I have taken example here, propene. I take here propene and let me explain here. Propene I take C. H, it is H, this is H, it is you see single bond C, it is double bond CH2, then this one is here H. What will happen in this case? This is called alpha carbon. This carbon is called alpha carbon. It has how many hydrogen? 3 alpha hydrogen. Out of these 3 alpha hydrogen, 1 alpha hydrogen, what will happen? It will lose both the electron to this. It is called sigma bond. It is called pi bond. That it is named as here sigma bond and pi bond electron interaction. This is called sigma bond. When it comes here, it is becoming pi bond. Is it not here? This. Then if it comes here, these 2 electron will go. Now how to write here means this is carbon. Now here you see this is hydrogen and this one is hydrogen. Here we don't have this. It is H plus. Now it is becoming double bond. Then it is CH. Now these 2 electrons are taken up by this. I write here CH2, it is with 1 minus. This called. Now you see this H plus ion is remaining there itself. It does not move because of this here pi bond electron cloud here. It is hanging there itself. It is strongly bound to the system. It is strongly bound to the system. Now I take and let me explain here how many hyperconjugative structures we are getting for propene. I take a propene. Here I take it is propene, CH3, CH2, CH double bond, CH2. I take propene, it is CH, it is H and H, single bond C, it is H, double bond, it is CH2. This is here it moves in this case. So what we get, it goes. Now it is becoming C, it is H, it is H, it is double bond, it is C. These two electron will go there, that is becoming CH2 minus. This is. Now again, instead of this hydrogen is left then here itself. Instead of this hydrogen it moves. So what will happen again? This side hydrogen goes, here H, no bond, here it is bond, it is bond, it is double bond, it is CH, single bond CH2. Now it is getting minus, so it is getting plus. It is getting plus. This is one structure, this electron, this hydrogen is losing electron, this hydrogen is losing electron, that goes here. Now I take a third structure, it is C, this hydrogen, third one, that is H plus, here this is H, single bond it is H, double bond it is CH, single bond it is CH2, it is minus. So totally for this propane, how many hyperconjugative structures are there? Then we will have to write total number of hyperconjugative system is equal to n plus 1 number. What is called n? N says total number of alpha hydrogen. You see, this is called total number of alpha hydrogen. Total number of, it is alpha carbon, total number of alpha hydrogen 1, 2, 3, 3, that is 3 plus 1. Total number of hyperconjugative structure for this propane is here 4. 4 is the hyperconjugative, 1, 2, 3, 4. We will have to draw the double-headed arrow mark like this. Headed like this. Is not here. Then this is called alkyl group. Now you all know that here inductive group, inductive effect. In this inductive effect, you all know that here the order of this inductive effect for alkyl group is this is, it is tertiary, then it is secondary, it is secondary, it is secondary, it is tertiary, it is secondary, primary. This is what I write here, CH3, CH2, single bond. This is, you all know that here a number of carbon increases. What will happen to the inductive effect? Inductive effect will increase like this. It is inductive effect. Inductive effect. But regarding here hyperconjugative effect, what is that here order? It is a reverse order. CH2, H. Now this is CH3, thrice C. This is, so this is order. Why this is order? You see, when it is attached with one carbon-carbon double bond or carbon plus or a carbon free radical, it is called alpha carbon. Alpha carbon, how many hydrogens are there? 2 hydrogens, 2 alpha hydrogens. But here, when it is attached with this, that here number of alpha hydrogen, it is alpha carbon, number of alpha hydrogen is 1 alpha hydrogen. But here it has here no alpha hydrogen is not. If number of alpha hydrogen increases, hyperconjugative effect or hyperconjugative structure increases. If the number of hyperconjugative structure increases, the stability of that compound increases, right? Other examples, more number of examples we will see in the next video.